All right, guys. So now we'll move on with the next part of the lesson. So previously we learned how to sketch all the inverse hyperbolic functions, right, guys? All right. So now we are going to learn how to express, okay, inverse hyperbolic function in terms of natural logarithm. Okay, so that's the whole point. Okay. So you're supposed to. So what we are going to do here is we are trying to represent, we are trying to express inverse hyperbolic functions in terms of natural logarithm. Okay, so that's the whole point. So here the first one. So the first one is here it's a question. The question says to show that r shine x is equal to the natural log of x plus root x square plus one. So you're supposed to show this. Okay, so let's get it done. Okay, so how does it work? So we are supposed to show that r shine x is equal to this, right, guys? Okay, so what we do here is we start by taking, we say let, okay, so let y be equal to r shine x, right, guys? Are you with me? Now, you know, r shine x is another way of saying shine inverse x, right, guys? So this r shine x is another way of saying shine inverse x. So in other words, I have here x equals to shine y, right, guys? Do you agree with me? Because this is in other words shine inverse x, right? So if shine inverse x is equal to this y, then shine y is equal to x, right, guys? So you should know this. That's a really basic stuff that you even learn in trigonometry, isn't it? And then, guys, what we do is we use our definition of shine y because we have the definition of shine y given to us at the very beginning, right? So we know that shine y is equal to e to the power y minus e to the power minus y divided by 2. So this was a definition of shine y at the very beginning of the chapter, right, guys? Do you recall? Yeah, so over here you can see this is where we started, right? So hyperbolic sign. So they have given here for shine x. Shine x is ex minus e to the power minus 6 divided by 2. Okay, so here it's shine y is ey minus e to the power minus y divided by 2. All right, guys? All right, guys. And then let's rearrange the equation. Taking 2 to the other side, I get here 2x equals e to the power y minus e to the power minus y, right, guys? All right, after you come to this point, so let's rearrange the equation. So you can see I have e to the power minus y here, e to the power y. So what I'll do here is I want to get everything to a positive power. Basically, we need to construct a quadratic equation here. So how do I construct the quadratic equation? I'll multiply the whole equation with e to the power y. So I get here 2x times e to the power y. Here e to the power y into e to the power y is e to the power 2y minus e to the power minus y into e to the power y is e to the power 0 when you add the powers. Right, guys? All right. So what do we get here? 2x times e to the power y is e to the power 2y minus e to the power 0. That's a 1. So guys, you can see that we have a kind of a quadratic equation here because e to the power 2y is like your, you can consider this as your a square, okay? And e to the power y is like the a, okay? So let's take everything together to one side, e to the power 2y minus 2x e to the power y minus 1. Right, guys, can you see? This is kind of like your quadratic equation, okay? So this is the quadratic part, okay, guys? So you need to solve this quadratic equation. Okay, so if I just give you a look here, this is a square minus 2xa minus 1. That's how it looks like. Okay, so where a is e to the power y, then a square is e to the power 2y. Okay, guys, so this is, you have kind of a quadratic equation here. And what we will do here is you need to solve this quadratic equation. So I think one of the easiest ways to solve, obviously, you don't, I mean, you can see it won't be factorized. So you can try to go for completing square, right? You can use the formula as well, or you can go for completing square. So completing square is the easier method here. So how does it work? Open the bracket and instead of, right, I mean, this is a x square here, you write x here, right? So here is e to the power 2y. So just without the power is e to the power y, right, guys? Because this is the x square. If there's x square in completing square, you write just the x inside the bracket, right? So remember here, this is, e to the power y is just the x here. I hope you guys are getting what I'm saying. These are like really basic P1 stuff. Okay. So e to the power y minus half of the coefficient. Right here, half of the EY coefficient. So 2x is the EY coefficient. Okay. So half of that is just x. Are you with me? Shall I show it to you in terms of, okay, let me finish this and I show it to you in terms of A as well. Okay, just to make sure you understand. Okay, so if I do this directly, this is e to the power y. You write the power, you write the quadratic component without the power minus half of the quadratic component, whatever you have over here, half of it. So it's 2x, half of it is x. Then you square, and then it's a minus, a compulsory minus, and the square of what you wrote inside here. So the square of x is x square, and separately there's a minus 1. All right, guys. So this is what we have over here. Just to show you how we do it, if I do it in the alternative way. So 0 equal, instead of e to the power 2y, it's a square minus 2x a minus 1. Right here, a is e to the power 2y. You can e to the power y. Okay, a is e to the power y, which means a square is e to the power 2y. So guys, over here, if you complete the square, you can see open bracket. Instead of a square, you write a minus half the coefficient of a is x, because 2x divided by 2 is x. Square compulsory minus, that's x. Again, you have to square the x, and there's a minus 1. So you can see it's exactly the same thing that I've written over here. The only difference, a is e to the power y. So you don't need to go through these steps. These are extra steps, but you can come to this directly. But if you have trouble coming to this directly, you can always go through these extra steps to come here. That's perfectly fine. Okay, guys. So, the target here, I want to get the show that for y equal r sin x. Basically, I want to get an expression for y. So, how do I get an expression for y? Let's make e to the power y the subject here. Okay. So, what do we get here? We get x square plus 1 equals e to the power y minus x whole thing squared. Right, guys? And then I want to make y the subject, so let's remove the square. When you remove the square, you get a square root, right, guys? And then you get plus or minus here, e to the power y minus x. All right, and then you can get here, guys. I'll write so I get here e to the power y equals x plus or minus square root x square plus 1. Right, guys? Are you with me? And then you can get you can remove the natural, you want to get rid of the exponent part, so you can take the natural logarithm of both the sides. So when you take the natural logarithm of both the sides, you get ln x plus or minus square root x square plus 1 equals natural log e to the power y. So this gives you y equals natural log of x plus or minus square root x square plus 1. Right, guys? Are you with me? Okay, and then we need to inspect the inside of this bracket a little bit further. Okay, so let's inspect inside the bracket a little bit further. Now, guys, when you compare x and x square plus 1, the root of x square plus 1. Okay, I want to compare and see who is larger and who is smaller. Okay, so what I'll do here is, let's make a comparison. I'll just square both the sides. Okay, so if I square both the sides, I get here x square, and the other side, when I square the root removed, then I get x square plus 1. So guys, you can see here, definitely x square plus 1 is bigger than x square, right? So which means if you square root both the sides, root x square plus 1 is bigger than x. Do you see? X square, the root of, x square plus 1 is definitely greater than x square. You can see that it's 1 greater than this guy. So which means root x square plus 1 is also bigger than x. Right, guys? So then what you need to see here is, now we have two options here, right? So you have either ln natural log of x plus root x square plus 1, or you have y equals natural log of x minus root x square plus 1. So what do you have to say here, guys? What do you have to say here? You can see x square plus 1 is greater. So if you are adding over here the inside of the logarithm, you are definitely having a positive figure. So that's fine. You're adding it together. But over here, guys, you can see x minus root x square plus 1. Since the root x square plus 1 part is bigger, Since this is greater than x, you can see the inside of the logarithm becomes negative. Can you see the inside of the logarithm here becomes negative because x square plus 1 is bigger than x, right? So the negative component gets bigger, and what you have one, and you get the inside of the logarithm becomes negative, right, guys? So you can see, you know that it's not possible to take logarithms of negative numbers. So then this is not a possible option, right? So then your only answer here for shine should be the natural log of x plus root x square plus 1. So this should be your only possible answer. Okay, guys. So guys, one more thing here. So who is our y? Y is r shine x. So basically we have an expression in terms of natural logarithms for the inverse hyperbolic function of shine x. Okay, so r shine x is natural log of x plus root x square plus 1. Okay, guys. So if you want to get the natural, if you want to get the inverse function, okay, so you don't always have to go with the calculator. You can also go with the r shine x, this natural log. You can take the answer by using this guy as well. Okay, so it's really easy if you want to find the r shine inverse of 2. So you just have to replace x with 2 into this equation, because sometimes they'll ask you to get the value of r shine x in terms of natural logarithm. So if you try to get the answer within the calculator, you won't get a natural logarithm answer, right? You will get decimal answer, but most of the time they'll ask you to get exact answer. So then you'll have to definitely go with this expression. I think you will find this formula in your formula book as well. Okay, guys. So now let's go for the proof of r cos x and r tan x. All these proofs are required, and you must know how to derive all these results. All right, guys. So let's also derive the expression in terms of natural logs for the cos inverse x. Okay, so r cos x. Okay, so let's do it. So we have here y equals r cos x, right, guys? So y equal r cos x. So I want to derive an expression for y in terms of natural logs of x. Okay. So we know cos x, r cos x is, in other words, cos inverse x. Okay. So cos inverse x is cos y is equal to x, not cos y, cos y, right? The method is the same as trigonometric. Okay. So if you have y equal r cos x, then that means that's cos inverse x, right? So that is cos y is equal to x. Same thing. Okay. 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 So I have here cos y is equal to x. I'll write here x equals cos y only. And we know we have an expression for cos x, right? In terms of exponents. So it was e to the power y plus e to the power minus y divided by 2, right, guys? So it was given in the very first page of the lesson. Okay, so e to the power y plus e to the power minus y divided by 2. So now repeat the process again. You're going to create a quadratic equation. So you get here 2x equals e to the power y plus e to the power minus y. And then to create the quadratic equation, you multiply the entire the equation with e to the power y. You end up getting 2x times e to the power y equals e to the power y into e to the power y is e to the power 2y. E to the power minus y into e to the power y, that's e to the power 0, which means, in other words, that's 1. Take everything to one side, arrange the quadratic equation, e to the power 2y minus 2x e to the power y plus 1. Right, guys? So this is your quadratic equation. Okay? So basically, this is like a square minus 2xa plus 1. Rearrange the equation. Let's go for completing square. So I'm going to solve the equation. So when I solve it, it's going to be open bracket, completing squares. E to the power 2y, we take removing the quadratic part. So it's e to the power y minus half of the component here. So ey. Okay, half of the ey component, the coefficient. So it's minus 2x, half of it is 1, just minus x. Close bracket square, a minus, compulsory minus, and squaring x here gives you x square. And then, guys, over here it's a plus 1. All right. Okay, so the same thing as earlier, but there are slight differences. Okay, just with the signs, right? Okay, so then let's make by the subject. So I'll get negative x square plus 1 here. So I get positive x square minus 1 equals e to the power y minus x whole thing square. Right, guys? And then let's remove the square. So x square minus 1 and you put the root and you get plus or minus. Right, guys? And then we can make ey the subject here. So e to the power y equals x plus or minus square root x square minus 1. Right, guys? Shall I just rewrite this again? E to the power y equal x plus or minus square root x square minus 1. You agree, right? And then you can use the natural log to both the sides to make y the subject. So let's use natural log to both the sides. And then I get here y equals natural log of x plus or minus square root x square minus 1. All right, guys. So again, you can see we have two answers, right? So we have two options here, plus or minus. Okay, so how do we go for the answer? So let's separate them. We have y equals natural log of x plus root x square minus 1. And the other answer, y equals natural log of x minus root x square minus 1. Okay, so now we need to check, inspect these values inside and see whether it's possible to go with both the answers, or are we only going to take one answer, right? So let's inspect inside. Okay, guys, so to inspect inside, okay, in this case, we are going to go for some extra, we're going to check a few extra things here, guys. Over here, when it comes to, now, we are dealing with R cos x. We are trying to get an expression for R cos x here, right, guys? So what I'll do here, you can see I've taken the graph of R cos x because I want to see it first. And we have described the domain and range of R cos x, right, very clearly. So you can see this blue graph here is the R cos x graph. And we have described the domain previously, right? So you can see here clearly R cos x graph is defined only for what? Only for x values greater than or equal 1. Right, guys? R cos x graph is defined only for x values greater than 1. Greater than 1. Okay, so R cos x graph is defined for x values greater than 1. You can see it here in the graph. Right? So we've described these things. So basically, this expression, yeah, whatever the x values you're gonna use here, you're only going to use x values greater than 1 in this expression. We are not going to work with x values lower than that. Okay. So the first requirement is that the x values you use here are always greater than 1. Okay. Why? Because we get it from the graph. Okay. Because the domain of R cos x is defined for x values greater than 1. So only x values greater than 1 are going to go in here. All right, guys. So now let's compare x and x square minus 1. Okay, root x square minus. Let's compare them. So x and root x square minus 1. I want to see who is larger and who is smaller. Okay, so I want to see which one is the bigger one, which one is the smaller one. So guys, how do I compare? So in order to compare them, I'll square both the sides. Then I'm going to get here x square. And when I square this guy, root x square minus 1, the square root removed. And I get here x square minus 1. So I think you can see when you compare, you can see who is bigger and smaller, right? So when you compare x square with x square minus 1, x square minus 1 is definitely smaller, right? So this guy is smaller. X square is larger in comparison. Can you see, guys? Comparing x square with x square minus 1. Okay, so x square minus 1 is smaller, which means x square is the larger guy. So in other words, when you root both the sides, x is the larger one. Right, guys? X is bigger than root x square minus 1. Are you with me? All right, guys. So with this requirement, now since you see that x is greater than root x square minus 1, so you can see the inside of this logarithm. This is definitely a positive part inside the logarithm. And guys, over here also, because x is bigger than x square minus 1, okay? So you can see that this is also positive now. This is also still positive. The inside of the logarithm is positive. Do you agree? In the R sin x case, the inside of the logarithm was negative here. Okay, so then immediately we know we couldn't take the log of a negative figure, so we immediately cut it out because we get math error here. But over here, you're not going to get math error because it's possible to take a logarithm of a positive number. That's possible because x is bigger than root x square minus 1. So you will surely get a positive figure here, right? So which means it's possible to take the logarithm of a positive figure. Okay, but okay, we need to inspect a little bit more here. Okay, we need to inspect a little bit more. Okay, so what do I mean by that? Now, guys, here the answers that you get for y. So again, looking at the graph. Okay, so y means the answers you get for this graph, right? So here, this is the graph of y equal r cos x. So you can see, guys, all the answers, the values of y are positive, right, guys? You can see the range. So now I'm talking about the range. Okay, the range of the y values for r cos x are all positive. You know clearly you will never get a negative figure for y, right? R cos x cannot give you a negative answer for y, only positive. So guys, now I want to just inspect a little bit more inside here and see what's happening inside this bracket. Okay, so we want to make sure that we get positive answers for y. So guys, what I want you to do here is, you're going to use x values bigger than 1, right? So let's actually use x values bigger than 1 and inspect what happens inside. Okay, and I want you and I want you to see what's happening, what's going on. Okay, guys. So to show you what's happening inside the bracket, so you can type a few values in the calculator, or you can. So I'm just going to show you a few values by using the Excel function. You can even just type it in the cal. Okay, you can see it. So here, you're supposed to use X values bigger than 1, right? So any value bigger than 1 is fine. So I've just used a few values here. And guys, over here, I have the function that's happening here, right? So it's x minus the square root of x square minus 1. So here my x value minus the square root of the x square, the square of that x value minus 1. Okay, so you can see I've given this function here. Okay, x minus square root of the x square minus 1. Okay, so you give that here. Okay, guys, so you can generate it for many x values as you want. So I've taken big x values. You can go, you can make it as big as you want. Okay. Okay, so you can see this is e is 10 to the power minus 6 here. Okay, so 5 10 to the power minus 6. That's what it says here. And then, guys, I'm supposed to take the logarithm of it, right? I want to take the natural log of this value here. Okay, the part inside the bracket. So I'm going to take the natural log. Okay, guys, so I'm going to take the natural log. Okay, so natural log of this part. Okay, and you can see now when you get these answers, you can see something here. The first thing you can see here is whatever the part that you get inside the bracket, guys, you can see all these answers are smaller than 1, right? So you get values which are all 0 point answers. And guys, when you take the logarithm of a 0 point answer, you know this in P2 as well, right? When you take the logarithm of a 0 point answer, guys, it's always negative. It's always negative. So what's happening here is the part inside the bracket x minus root x square minus 1 is always going to be smaller than 1. You always get answers that are less than 1. And what it creates is, it creates the logarithm of this. The logarithm of such a person is always negative. Therefore, okay, it's bigger than 0 and greater than 1. Okay. So therefore, the logarithm of x minus root x square minus 1 is always negative. You will definitely get the answer here as negative. But you know that r cos x is not negative, right? Because r cos x, the answers of y, the y answer should always be positive according to the graph. The graph always has only positive answers for y. So we don't have negative values. The graph doesn't continue down, right? Okay, so but r cos x is positive. Is positive. Therefore, this solution can be removed. You remove this solution. Okay, so we only have one answer here, guys. So we only get to work with y equals ln x plus root x square minus 1. So we only get to work with this. And y is r cos x. Okay, so this guy, you will get the answers. You get the answers for r cos x properly with this function. Okay, you don't have any problems. So guys, over here, the reason that you get this extra part, I think you remember, right? Because the original cos x graph had this function here as well, right? And you remember when we go for the inverse graph, I told you the original function needs to be 1 to 1. So you remove this part, right? So that's why this part of the graph is removed, right? Because in order to go for the inverse, we remove any part that makes it many to 1, and we make the graph 1 to 1, and then we reflect. So that's what happens here, right? So that's why the other part of the solution is removed here, the part that goes below the x-axis and gives you the negative y value. So those are removed from the r cos x graph, so we don't need it. Okay, guys, so this is the expression for r cos x. All right, now similarly, let's derive an expression for r tan x. All right, guys, so let's do the proof of y equal r tan x. So this is gonna be tan y is equal to x, right, guys? Tan y is equal to x. So let's get the show that. So what was the expression for tan y? So here tan x is sin x over cos x. So it's also given as e to the power 2x minus 1 over e to the power 2x plus 1. That's for tan x. So we are going for tan y. So it's going to be e to the power 2y minus 1 over e to the power 2y plus 1. Right, guys? Equals to x. And then let's make, let's rearrange the equation. E to the power 2y minus 1 equal x times e to the power 2y plus x. All right, guys. And then I think you can see in this case, we don't need to create a quadratic equation because it's possible. I mean, yeah, e to the powers are, I mean, the e to the powers are similar. E to the power 2y in all the places. You don't have different powers of e to the power 2y. So we can work with it easily, right? So take all the e to the power 2y's to one side and you take e to the power 2y out. So it's 1 minus x. Right, guys? So e to the power 2y equals x plus 1, or you can say 1 plus x over 1 minus x. So over here, you don't have a lot of trouble, right, guys? And then you can use the natural log to both the side. So you get here 2y equals natural log 1 plus x over 1 minus x. And then y equals half of natural log of 1 plus x over 1 minus x. Right, guys? Are you with me? All right, guys. So I think you can see we got to show that. But what about the domain, modulus x less than 1? So to understand the domain, you can actually visit the R tangent graph, right? So we discussed the graphs very clearly in the previous videos. So you can see here the R tangent graph. Here the domain is for x values between -1 to +1. This is another way of saying modulus x is smaller than 1, right, guys? So it's the domain, basically the domain of R tangent graph. So that's how you get this. So this graph is only defined when modulus x is less than 1. Basically, you are only supposed to use x values between -1 and +1 into this function. You're not supposed to use any other x values. So here y, in other words, is your R tangent. So half of the natural log of 1 plus x over 1 minus x, and we have our answer. All right, guys. All right, guys. So basically, I think you can see here now. Here, for example, you can see what they've done here in these examples. Express as natural logarithms. R shine 1. So of course, if you go to give R shine 1 in your calculator, you know you'll end up getting decimals. But if they want natural logarithms, so guys, what do you do? To get the value of R shine 1, you take the R shine x function, replace x with 1. That's what they've done here. So R shine 1 equal natural log of 1 plus root 1 square plus 1, which gives you natural log of 1 plus root 2. Can you see, guys? R cos 2, if you need the answer in terms of natural logarithms, you have to go with this expression. Okay, so for x values greater than or equal 1, the R cos x only works for x values greater than or equal 1, right? So we know that from our graph. So only for those values, this the graph is, the answers are going to work. Okay, so you're going to substitute the value here, and you're going to get and you can see you can get the answer here. So that's really simple, right? The natural log of 2 r cos 2 x is replaced by 2. Natural log of 2 plus square root of 2 square minus 1. Okay, guys, and you can get the answer here. So these are all like very simple calculations, right? So you can leave your answer in the exact form. And guys, over here, so these, I think we've discussed all these graphs, right? So we've done all of these stuff now. Okay, so I believe these are all, I believe these are like really easy, right? So maybe we can do, maybe, yeah, we'll just do maybe Yeah, so maybe we'll do one question. Fourth one, part A, R shine 2. So R shine x was natural log of x plus root x square plus 1. So R shine 2 is natural log of 2 plus root 2 square plus 1, which is 2 plus square root of 5. Okay, 2 plus square root of 5. Okay, guys, so these are like really easy. Okay, all you need to do is to substitute values into the equation. Okay. All right, guys. So we'll do question number 7, right? So I think the other questions are easy. So here they say, given that r tangent x plus r tangent y equals to natural log of root 3, prove that y equal to x minus 1 over x minus 2. All right. So you can directly use the results that you proved for r tangent x. So that's half natural log of 1 plus x over 1 minus x. Plus half, this is natural log of r tangent y will be 1 plus y over 1 minus y equals log of root 3. Right, guys? Can you see? Okay, so you need to get this show that basically they have made y the subject. Okay, so you need to think of the easiest way. You need to kind of simplify it. How do you simplify this in the easiest way? Okay, because there are ways of doing this that's going to be very difficult, right? So we need to do this in the easiest possible way. So what I see here is, guys, I can see there are natural logs everywhere. Okay, and if you have logarithms, you can bring them together. But however, you can't have coefficients out there. This half need to be removed. Okay, so one way of removing the half is to put it inside as a power, but that's not what I'm going to do because that's going to create more difficulty, I believe. So what I'll do here is first to get rid of the half. It's an equation, right? This is the equation. I'll multiply the entire equation by 2. Why am I doing this? Then I get here the half removes natural log of 1 plus x over 1 minus x. Plus here natural log of 1 plus y over 1 minus y. And here I get 2 times natural log of root 3. Can you see? And now you can see I've removed the half here, but there's a 2 here. And guys, we can now we use this 2 inside the logarithm as a power. And when you're using as a power of 2, that's a lot easier, right? So you get the square of root 3, right? That's a lot easier for us to work with. So here, natural log of 1 plus x over 1 plus y plus natural log of 1 plus y over 1 minus y equals, you get here log of root 3 square. Root 3 square is going to be 3, right, guys? So that's removing a root here. And guys, when you are adding, when you add two logarithms, it's going to give you the product. It's going to give you a product of a single logarithm. So it's going to be 1 plus x over 1. Sorry, this is the 1 plus x over 1 minus x, right, guys? Here. 1 plus x over 1 minus x. It's 1 plus x over 1 minus x into 1 plus y over 1 minus y. Inside the single logarithm, it's going to be natural log of root 3 square is 3. Right, guys? Is that correct? Okay, so we come to this point, and now you can see both sides we have a natural logarithm, right? So we can get it off the, we can compare inside the natural logarithm, and you get here 1 plus x, 1 plus y over 1 minus x, 1 minus y is equal to log of, not log of 3, just 3, right? Just 3. Why? Because we are comparing the values inside the natural logarithm. So you get this part, okay, is equal to 3. And then I get here, guys, so we need to expand the bracket because we are supposed to make y the subject. So let's expand the bracket, make y the subject. So I get here 1 plus y plus x plus xy. The denominator I get 1 minus y minus x plus xy equals to 3. So multiplying, I'll take this denominator to the other side, multiply it with 3, and I get here 3 minus 3y minus 3x plus 3xy. So guys, let's take all the y terms to one side, right? And take all the terms without y to the other side. So y plus xy plus 3y minus 3xy equals 3 minus 3x minus 1 minus x, right? I took this 1 and x to the other side. 3 minus 3x minus 1 minus x. So taking y out, I get here 1 plus x plus 3 minus 3x, right guys? Here I get 3 minus 1, that's a 2. 3x minus x, that's minus 4x, right? And here I get y, and here 3 plus 1, that's 4 minus, not minus, it's 4 plus x minus 3x, yeah. That's minus 2x, right? So we get here y equals 2 minus 4x over 4 minus 2x. I think we can take a factor out. 2, then when you take, it's 1 minus 2x, and when I take a factor 2 out, it's 2 minus x. Right, guys? So we can cut off the 2, and I get y equals to, the 2 cancels, you get 1 minus 2x over 2 minus x. All right, guys? So this is, I show that, right? 1 minus, 2x minus 1 over x minus. Okay. So have I got the show that? Now you can see in there show that it's 2x minus 1 over x minus 2. But you can see I got it there. I got it almost, right? But I have 1 minus 2x over 2 minus x. So if I answer different, actually, you should, and I think at this point, you guys should be capable of knowing that actually this is the exact same as what we have over here, right? So basically, it's just multiplying up and down by minus 1, right? Yeah, you multiply your numerator and denominator by minus 1, you don't make any difference. And then you get 2x minus 1 over x minus 2. So guys, you should know that these two fractions are actually equivalent. Okay, so it's the same thing. All right, guys, so we have the answer here. Okay, guys, so I hope you understood this part perfectly.